Welcome to my YouTube channel. I'm Joan Amara. Today we are going to continue our preparation for the exam on matrix theory. And from where we stopped last time, we're going to continue from rotational matrix. So rotational matrix, you can be asked to rotate a plane or you are asked to rotate a point. The first one we did last time is rotating a plane. If we have our normal partition plane, if you have a fixed point P, this distance between the origin and P is, say, R. If you are asked to rotate this whole plane to give us something like this, about an angle, first of all, let's say this is theta, and we are asked to rotate about an angle alpha. So, and alpha is less than theta, alpha is less than theta. Then we'll have that the new plane will be something like this. So this is x prime, y prime, and this distance here must also be alpha. This distance will be alpha. So to see this clearly, I'm going to draw these two separately. Okay? So this is the first plane, the usual partition plane.
This is theta.
And then this. This is x. This is
That's x
our
prime.
point. X prime, thank you. Y prime. This is our point. So this new angle here is theta minus alpha. Because if this whole angle is theta, then this is alpha and minus. So this is also r. Our aim is to get what x and y is related to this plane. So normally the standard that our x is equals to r cos theta and y is equals to r sin theta. Now this rotated matrix is just the same thing. X prime is equals to r cos the angle now is theta minus alpha. Then y prime is r sin theta minus alpha. But we don't want theta. It was rotated about alpha. We need to find a way to remove that theta. We call that cos A minus B is equals to cos A cos B plus thank you, sin A sin B. Then sin A minus B is equals to sin A cos B minus cos A sin B. So applying this to this is y prime. Applying this to this, we would have x prime is equals to r
into
cos
theta sin
r into cos theta cos alpha plus sin theta sin alpha. And this will give us r cos theta cos alpha plus r sin theta sin alpha. Why I group this is because we can see clearly that this is x and y. So this is x cos alpha plus y sin alpha. And if you do the same thing for y prime, you have r sin theta cos alpha minus cos theta sin alpha, right? Collect we have r sin theta cos alpha minus r cos theta sin alpha. And this will give me what? Y cos alpha minus x sine alpha. So what we have now is that this is equal to x cos alpha plus y sine alpha. While this y prime is equal to, I want x to be the first, so I have minus x sine alpha plus y cos alpha. Is it clear?
Yeah. We did this last time, so
Okay, so
it will be clear.
this means that if I put it in systems of equation, this side is x prime y prime is equal to, I'm going to push out x and y. So I take the coefficients, I have cos alpha, sine alpha, sine minus sine alpha, cos alpha. Good. So that's all for rotating a plane. The next is to rotate a point. Are we done with this? Are you writing?
Yeah, we are coming to write. This is what we did yesterday.
Yes.
I did plan to do this. I have to present this to
So that's all you need to know about rotating a plane
Okay.
about an angle. This is plane about an angle. Next, we'll do rotating a point about a plane. So here, when we rotated the plane, it was the plane that shifted. Next, we are going to shift the point and keep the plane fixed. Okay, so let's do that. So let's reflect a point P about the x-axis. Now, when we say reflect, first of all, let's draw what it will ordinarily look like. This is x, this is y. Suppose this is P. You can put your point anywhere. It's the same procedure. So this will be r, and then this will be say theta. Now, we say we should reflect about the x-axis. It means that we are going to keep the x-axis fixed. This point is x, y, right? Yeah. So we are going to keep the x-axis fixed, and then reflect it considering the y-axis. So it's going to be here. Yeah. Because here we have the same x, but a new y.
Okay, either minus y.
Yes, you can call it minus y, but it's a new y. So, what does this mean? This angle is still theta.
It's still theta, yes.
But our aim is to find what this angle is.
Okay. Which is 2 theta, whatever. 2 pi minus 2 theta.
You can just call it, no, from this point, you're always considering from this standpoint. Okay. There are two ways to see this angle. This angle can be seen as 360 minus theta, or another person can see that if I reflect it about this point, it will be a 90 degrees rotation. The same thing about here, another 90 degrees, then another 90 degrees. So that's plus 270. So that would be 270 plus theta. So either this or this should give you the same answer. So let's see how that works. So we have two planes here. Let's see that plane. Two things happening. We have this theta r p x y y x, and then we have here p, or we could call this p prime. Don't need to state what the points are. And that was p. So this will give me, which one should be used? 270 plus theta or 360 minus theta? Or we use both?
270 plus theta, like plus is always makes sense.
270 plus theta.
I want to use 360 minus.
Then why are we not answers?
I will use both.
Yeah, we're with 360 minus
270 plus theta.
Yeah, we're with 260 minus
So this is still x, y. Okay? So we know that x is equals to r cos theta and y is equals to r sin theta. Here we have that
Alpha is now 360 minus theta.
no, the whole angle is 360 minus theta,
Yes.
not just alpha. So we have r cos 360 minus theta. We should go ahead and simplify, right?
Yep.
So this is equals to r cos. Let's remind ourselves.
No,
We
no,
said
no.
cos A minus B is equals to cos A cos B plus sin A sin B. And we said that sin A minus B is equals to sin A cos B minus cos A sin B. So we're going to put it here. So we have this is cos 360 cos theta minus sin 360, sorry, this will be plus sin theta. And this will give me r. What is cos 360 degrees? One way.
No?
Oh, it's one actually, it's correct. One way to see it is cos starts from here, cos 0 is 1. Cos 180 is minus 1.
Plus 1.
Cos 360 is plus 1. So that's 1. So I don't need to write it. I have cos theta sin 360 0. So that side goes up. Then
Y prime.
y prime is equal to r, because this is x prime y prime. R sin 360 minus theta, which will give me r. Considering this now, we have sin 360 cos theta minus cos 360 sin theta. Okay, so this becomes 0. So we can throw it away. This is just r minus, sorry. Cos 360 is still 1, so we have minus r sin theta. So what do we have as our new?
Our x prime is the same as x, while
Yeah.
our y prime is equal to minus y.
Our y prime is equal to minus 1. We have even seen it from the rotation.
Yeah,
There was all this was just for.
just for the mathematical
So
completion.
we have that this is x plus 0y, right?
Yeah.
And this is 0x plus y. So the matrix x prime, y prime will give me 1, 0, sorry, minus 0 minus 1, x, y.
Yes.
So some areas of application of matrices are geometry, which we just did. We also have OD, and then we have systems of equations. So we are going to be taking systems of equation now. What are systems of equation? For example, if you have x1, no, if you have ax plus by is equals to c, and you have another one like that, a2 plus b2y is equal to c2. What kind of equation is this?
Simultaneous equation.
It is simultaneous equation. What if they increase it to a1x plus b1y plus c1z is equal to
D, y.
d1
True.
So why did they increase it to this? Is this still
No,
a...
because they're playing.
Is this still a simultaneous equation?
Yes, no.
It's still a simultaneous
Only
equation.
that the dimension has changed.
When you are given a simultaneous equation, you can transform it to a system of equations. So all you need to do is take the coefficient of x and y. You have a1, b1 in the same position, please. a2, b2,
X1.
x, y. If you multiply these two matrices, you should get this back.
Yeah.
And this is equal to
C1, C2.
C1, C2.
C2, column
By definition of equality of matrices. The same thing here, you have, this is the same thing as A1, B1, C1, A2, B2, C2.
X1 is equal to B1 to this with column matrix.
Sometimes a simultaneous equation may have infinitely many solutions. And like the ones they taught us in secondary school, it may have unique solutions. Like you can just easily solve it. And then sometimes it will not have a solution.
Yeah, no solution.
So we are going to see cases when they have unique solution, they don't have solution, or they have infinitely many solutions.
Okay. Crammer.
People that like to cram. Crammer rule. So Crammer rule is an easy way to solve simultaneous equations. So what I'm going to do is I'm going to just write out the formula. There's no need to prove it. We have delta is equal to A1, B1, A2, B2. Delta 1 is equal to B1, B2. So I'm going to teach you how to easily see it. The first one you have, which is delta, is exactly this matrix.
Okay.
The determinant of that matrix.
Okay.
Right? Yes. The determinant of this matrix. The second one you will see is if you put A1, B1, C1, A2, B2, C2. You put in matrix form. You need to close the x axis, the first one, and you have the second one that you want.
Yeah. C1, C2.
So just get the determinant of this. And then the last one, which is
That's true.
delta 2, is equivalent to closing this row.
Yeah.
I don't know how to close it without blocking the last one. So you close this two and you have determinant of A1, C1, A2, C2. So you should never forget it. Remember you close the first row, which is usually X, Y, and then the answer, right? Now you close this first row to get this one.
Yeah.
Then X is equals to changing
Yeah.
over.
Determinant.
Yeah.
Yeah. Determinant.
They are all determinants, please. And then Y is equals to.
Delta 2 over delta.
So can we take examples? You can try it by yourself.
No, no need for example. Just move on. I mean, go ahead and say. Yeah?
Then
We know you're a mathematician.
No. It's not because of that. It
No,
will take
you're a
time.
mathematician and you're very good.
I want to see if I can get.
So,
Okay,
I'm not
let's
sure.
see if I can
Yeah, I want to see you.
So please, this one now is not GIS. This is mathematics.
Okay. What I'm trying to say is there in the notes, whatever.
Okay, so if you have x plus 2y, x minus 2y
Okay.
is equal to 1 minus 1. Let's try it if we can solve it.
You cannot get the second part of the board back unless you use white marker.
We had chalk also. We use chalk also.
Because
Okay.
this one will require cleaning the board also. Maybe
I would, as much as possible, we will not need to clean it.
please.
So
Or
we have,
take the snap before you clean.
putting this in matrix form, we have 1, 2, 1, minus 2. Now, instead of doing all this long story, you can do it like this and just put.
Yes.
Okay.
That's what
So, I'm going to do that. Put 1, minus 1. So, what is delta? Delta is the determinant. I'm not taking determinant now. Of 1, 2, 1 minus 2. What will this give you?
Minus 4.
0. Okay, it's 4.
1 times minus 2, minus 2, minus 1 times 2, minus 2, so that's minus 4. D1 is equal to, you are closing this row and using this row. You have 2, 1, minus 2, 1. Why not thinking like 0 now?
Minus 1.
Minus 1.
Okay.
Minus 2 minus 1.
So this times this plus this plus this times this minus this times 0.
Minus 3. Should it be 0?
Yes, it should be 0. Check it now. 2 times minus 1 minus 2.
2 times 1.
Minus 2 times 1 plus 2.
Okay.
So
Yeah.
delta 2 is what? Delta 2 is closing this row and having
1
minus 1. So that will give you what?
So give us 0 now also.
No, it will give you this time
Okay,
is
this is
minus 1
minus 2.
minus 2. So therefore, x, which is changing 1 over delta, is equal to 0.
Yeah.
If I divide by 4, it's 0. Minus 4 rather. Then y is equal to changing
Minus 2 over minus 4, which is 1 over, which is 2. Okay, 1 over 2.
chicken up. That's the end.
Yes.
So your answer is x, y is equal to 0.
0. Yes. So let's take
So,
the picture before you.
basic properties of matrix. Here we're going to be looking at properties relating to inverse of a matrix. So first of all, let A be an n by n matrix. Who is that noise maker?
Well, did you just write this like, or it has already before now?
It has been there before now, so you better
Oh, you
leave
are
it.
using it. Okay.
Maybe she
So,
knows this.
let A be an n by n matrix. Let B be the inverse
Okay.
of A. First of all, observe that A is a square matrix. We only talk about inverse when it is a square matrix. If they give you a matrix that is not a square matrix and say find the inverse of that matrix, you say what? It does not exist.
Simple.
No.
One second answer. B.
So let B be the inverse of A. Then
Are you there?
Yeah.
Okay.
B is an n by n matrix also. And A times B is equal to B times A is equal to the identity in n by n matrix.
Yes.
So when before we showed you that multiplying from the right may not give you the same result as multiplying from the left.
Yeah.
So if I have any two matrices that when I multiply from the right and I multiply from the left, I still get the same matrix. They are equal. Then it must be the inverse of the other one. One thing you must know is that inverses are unique. I'm going to write that boldly. Inverse, if it exists, must be unique. Okay, fine, unique. Let me know the grammatic.
Is unique.
Potential question. They can ask you to show that, Abi.
Is unique.
The exam can ask you to show the inverse matrix is unique. Is it possible they ask such a question?
Yes, it's possible. You want us to show it?
I don't know the mood of the class.
Cool, what happened?
Cool doesn't take coffee today, so I'm sleepy. Huh?
Let's prove it.
He's looking for Cameroonian coffee. There is no Cameroonian coffee
Proof. Can we prove it?
here. Yes.
Let B1 and B2
The
be
inverse
inverses
A.
of A.
Okay.
By definition, B1 is equal to B1 times I times the identity matrix. Is it not true?
B1 is what? Yeah.
If I have B1, it's same as multiplying B1 with
By
identity
I.
matrix.
Okay.
Is it not true?
Yeah.
By definition of I, B1 is times I is A times B2.
Yes.
Right?
Yes. Are you getting there through this way?
Is A times B2.
Okay. Yes.
By associativity of matrices,
Yes.
this is equal to B1 times A times
Then
B2.
times B. Okay.
By definition of inverse, this is I
Yes. It is B2. So B2 is equal
times B2.
to
So this is equal to B2. So we have successfully proved that B1 is
B1
equal
is
to
equal to
B2.
B2.
Now, if you want to consider the way I taught you to prove, I said, what do you know? We know the definition of inverse. It said we should. It said if inverse, if it exists, is unique. So one that we want to prove. We know the definition of inverse, which we have above. And we know that uniqueness means that if there are two matrices that are inverses of A, then they must be equal. So that's where we are going to. So what do I know? I know that B1 is equal to this.
Yeah.
Then I now use properties, definition of
Is that one associative property or is it Q?
This here is definition of inverse. Here is associativity.
Associativity.
Can you explain that definition for me?
Inverse.
That first line, can you explain it?
This first line. Okay, if I have a matrix, any matrix in the world, maybe an n by n matrix, and I multiply it with the identity matrix, and there is still n by n, you know it's multiplicable. It will always give you that matrix. That's what I know. What I have is, I have IN, I have AB, I have this. The only thing I can use to relate to this is this I, because I know that B is equals to B times I. So B1 is equals to B1 times I. But according to this definition, it is still AB and it's still BA.
Yeah.
I observe that if I write B2A, I will not have problem. I may not have problem because of definition. I can still write it equals to A B2 because B2 is an inverse. You can still go that way, but it's longer steps. Do you understand? So I now wrote that this is equal to this. Then associativity property. We remember that we said that if you have A, B, C, is equals to A times B times C. Is equals to A, B times C.
Yeah.
So I just want the brackets. And then I looked up, this is the I,
Yeah.
my definition of inverse. And I times B is still B2. That's all.
That's how we want to be equal to B2.
It's the mountain I have.
When
Mountain.
It's the mountain.
No, tell the teacher so that she
No,
clear your
no,
mountain.
no,
Ah, okay.
I'm telling you, it's Nigerian mountain.
But yeah, sit here and do traffic.
Is it impossible? Is it impossible to Is it giraffe is not possible?
so I wanted to say something.
Yes, bro.
If a matrix is invertible, it means it's non-singular. Listen, non-singular. That means that I can find two matrices, that when I multiply them together, either from left or from right, I will still get I. So it's not singular. Do you understand? That means that inverse exists. Okay. If inverse exists,
Yes.
then that matrix is said to be non-singular because it has an inverse. Now, if the inverse does not exist, then it's singular. It exists on its own. I cannot find an inverse.
Okay.
Do you understand?
It can only remain simple.
Yes.
Yeah.
So, a matrix is non-singular if and only if it is invertible.
Wow. You better write it too.
A matrix is non-singular. This is the definition, so you don't need to prove it. If and only if its inverse
exists. Its inverse exists.
Proposition. Suppose that A is non-singular.
Proposition.
Then A times X is equal to 0 implies that X is equal to 0. I'm going to prove it.
Okay.
But you should help me.
Suppose
It's not singular.
Proof. So what do we know?
We know that A is not singular.
What does it mean for A to be non-singular?
It has an inverse.
Thank you. Inverse exists. So what we know is that assume that inverse exists. That means there exists an A inverse, right?
It never exists.
Such
It's
that-
automatic now. Once we propose that A is not singular, there is no assumption again. A has inverse. Simple.
I like the way you write it when you can say it like that. You can say it when you want to say it. So I think that there is zero when you are such that A inverse times A is equals to A times A inverse is equals to I. Right?
Yeah.
That's the first time. The next one says that then, so this is what we are trying to prove. So let's start from here now. We have A.
what is that sign you give like?
Is there exists? There exists. The inverse, the reverse E is there exists.
So we have AX is equal to 0. What does it mean? I can multiply.
When you spend it out and subtract it out.
I can multiply A inverse from the left.
Yes.
Yes, ma'am.
So I have this is implies that A inverse times A times X is equal to A inverse times 0. Now be careful.
Okay.
Don't go and write A
Times
times X A inverse is equals to A inverse times 0. I will tell you why they are wrong first of all.
Yeah.
So you have A times A inverse times A times X is equals to 0 times A inverse.
Okay.
Or which other way is wrong now? A times A inverse times X is equals to A inverse times X.
So
Times zero.
the order matters.
Or yeah, you say 0 times A inverse.
Okay.
Yeah, all wrong.
The order matters.
The reason is because in matrices, order matters.
Yes.
The order in which you multiply matters. So if you are multiplying from the left hand side, you must continue it even when you cross the equality sign. It must always be at the left hand side. If you start multiplying at this other side from the right hand side, when you cross over the equality sign, you must also multiply at the right hand side. And you cannot manufacture an A inverse and put it in between.
Okay.
And say it's equal to this. You will get the same solution, but you'll be wrong.
Order matters.
Other matters.
I don't even understand why you say
You don't understand why it is wrong.
Other matters. Or notification. She said multiplication does not complete.
Are you serious? Or you are joking?
I'm serious, now am I joking?
Multiplication of matrices is not complete.
In general,
It's not complicated.
thank you. A, B is not equal to.
Yes, that's true.
So,
In this case, our A.
so I cannot come and say A inverse times AX because this we are seeing as one matrix now is equal to 0 times A inverse.
Yeah.
I cannot say it.
Yeah.
I cannot say.
A inverse times 0. No, it will not be correct.
I cannot say AX A inverse
Oh, okay.
is equal to A inverse X. This is more equal to this. That's the problem.
Simple. See what? Simple.
But it's not multiplication.
Okay.
Multiplication.
Don't tell you now. Never write numbers, okay? Go on.
So what do we do here? We multiply the left hand side by A inverse. So this implies sign which I came from. So this implies that by definition above, I times X is equal to 0. But what is I times X? X is equal to 0. Have we not reached where we are going?
It's just somehow to me.
It's so easy, you get confused.
It's not so. I don't know the same thing. See, X equals to 0. Therefore,
You know what to do, but I don't know how to do
the
it.
first one.
That's a good matrix.
Okay, now this theorem does not stop here. It says if and only if.
Okay.
So what we have shown is the if. It remains the only if. So this is forward proof. I just showed this implies this. Now I want to start from here and show this. So what do I know? I know that X is equal to 0. Simple. Multiply both sides from the left hand side by X. Now we are done.
So that is the solution.
And here we know that A is. How do we know if A is 0 or not? Because A is
Whether it is invertible or not.
A0 is 0.
They say if and only if. What do we know? Or you can take a non-singular matrix. But whatever matrix you take, it will still give you 0. Whether it's singular or not. The first property of inverse is that A inverse is equals to A. Is equals to A. So what are we supposed to show? We show that what does it mean for A inverse is equals to A? It means that if I multiply A inverse by A, that I will have, we show that A inverse times A is equal to A times A inverse is equal to I.
That's what we do.
Yes.
The proof of it.
But what do we know? We know that we already done what?
That's all.
That's all. We know that
What happened?
A inverse.
She wrote something down.
Is it not? It's okay.
We know that the inverse of A is A, right? Is A inverse
Yes.
of A is A inverse by definition, is it not?
Yes.
By definition. What by definition? What does this mean? It means that A times A inverse is equals to A inverse times A is equal to I. Are we not done? By definition of the inverse of A is We are done.
But in indices,
But I thought
it's
it
the
says
same thing.
prove that A inverse is A.
Yes.
So you're not saying anything.
For example, you can take, if you want to see it clearly, you can choose to take that A inverse. Take A inverse to be equal to B. So what are we showing? We are showing that B inverse is equal to A, is it not?
Okay.
Right?
Yeah, it's good.
By definition of A inverse, what does it mean? It means that A inverse times A is equal to A times A inverse is equal to I. But A inverse is B. So it means that B times A is equal to A times B is equal to I. Therefore, A is equals to B inverse. Is it not? My definition of inverse. Why are you confused? See the definition here. That's why I'm not clear with. See, we took this to be B.
You have to start from the
We want to show that B inverse is equal to A. It is enough to show this, is it not? So, but we know that the inverse of A is A inverse. So by definition of that, we have this happening. But we define A inverse to be B. Right? We define A inverse to be B. So anywhere I see A inverse, I put B. Anywhere I see A inverse, I put B. Because then B inverse equals to I. That means that what? A is equal to A inverse inverse.
Yeah, A is equal to B inverse. That's what it means. It's equal to I. Where noted.
It has now
Action.
more action. So, proposition.
Another proposition.
We have two more propositions.
Okay.
Number one, A B inverse is equal to A B inverse A inverse. And A inverse transpose is equal to A transpose inverse. Who wants to try?
Okay, so why is the order important there? It cannot be A inverse B inverse.
No, it cannot be A inverse.
It has to be the reverse order B.
Yes.
So,
So, the easiest way to do it is to use the definition. Prove the definition. So we said that B is the inverse of A is this whole, right?
yes. It says so.
So we want to show that who is making noise now?
Sure. It's precious.
Precious.
It's precious.
We want to show that A inverse, AB inverse is equal to B inverse A. So it's the same as saying that the inverse of AB is equal to B inverse A inverse. I was fast.
Yeah, please come again with that.
We want to show that this is equal to this, right? So I said it's the same thing as showing that the inverse of AB is equal to this. So I need to show that whether I multiply it from the left or I multiply it from the right, it must give me an identity matrix.
Yes.
So A, B inverse times B inverse A inverse. Sorry, the proposition is not complete. Let A inverse let the inverse of A be A inverse and of B be B inverse. Sorry. Now we can show this. So this is equal to associativity. I can remove the brackets. I have A, B inverse, A inverse. Associativity, I can take this too.
Yes.
So this is equal to A, my definition of inverse, I, A inverse. Right?
Yeah.
My definition of inverse, of identity, is just A inverse. But A inverse is equal to I. So this is left hand side.
Yeah.
We now want to multiply it from the right hand side. Yeah? D inverse A inverse times AB. If you stop here, you get half.
Okay.
Get 5 marks out of 10, right?
No, if it's 10 marks, they'll give it 2.
If it is 2,
Because you can't even conclude that.
if it is 2 times 8,
They'll give it 2 or 3. So this is, I remove the brackets again. I have B inverse A inverse A B. Then collect these two together. We have B inverse B. Because this is I. And then this is equal to I. Therefore, A, B inverse A inverse is equal to I is equal to B inverse A inverse A B. Therefore, A B inverse is equal to B inverse A inverse. Yes, now. Second one on classwork. I've not done any classwork today. So A inverse transpose is equal to A transpose inverse. I will just give you hints. Hints. A B transpose is equal to A transpose B transpose. So you can take 2 minutes to do that. Okay, let's solve it first.
Yes, I do that.
I saw you.
He is not good at
See handwriting. Ha!
Oh
Professor.
my god. I used to look for his notes. His notes is very clean.
Nice handwriting.
You're not saying anything.
Is it obvious?
Obviously now.
Obviously.
Come on. It's very easy.
Yeah. Huh?
Right?
Yes, bro.
I took a transportation.
Now you know what to do.
Wow. I have thought of it this way.
Yes.
You have to do the backwards. That's the problem. He did this part. He didn't do this part. You did only multiplying from the left hand side. You didn't do the multiplying from the right.
I understand.
That's what I'm saying. You just switch from here. That inside, but when you have the second line, when you have A inverse, you just switch it because A inverse is
I didn't put at this side. I didn't put this side at this side equal to
A inverse A.
Then you take the transpose
equals to open bracket A inverse A, all of them transpose. And the same thing as splitting them. A inverse
transpose.
Next line A transpose. You cannot say that done now. I think they are done.
But if you throw away that side, I'm not done. So if you want to show that the inverse of something, yeah. If you wanted to show that A inverse is equal to B, we show this. A times B is equal to B times A is equal to I. So if I want to show that A inverse transpose is equal to this, this is the one that we are saying. We want to show that the inverse of this is equal to this. So I'll multiply this with this and see where it leads me to. It's supposed to lead me to I.
Okay.
So, solutions. I have A transpose, which is my A, which is this one, times A inverse, this time is recording. Pressure 0.
Just continue your work. What's your problem?
A transpose inverse. Okay. So I'm multiplying this with this. But by that hint I gave you, this is A inverse transpose, which is equal to I transpose equal to I. So this is the first side. The next side, the backward, multiplying from the right, you multiply with A transpose. And you have the same thing, A inverse A transpose is equal to I transpose is equal to I. Now you can conclude that A transpose, which is what you multiply with that, the inverse of that is exactly A inverse transpose. So either you do it this way or you do it this way. Simple, right?
With Panadol, it will be
Hey! So the next thing I'm going to do is determinant. Determinant is the whole topic on its own.
I will not go back to grammar school until next time.
Well, maybe we'll come out tomorrow. What do you think?
Now?
Should we come out tomorrow?
We can come out on Saturday. Huh?
We need payouts.
Do they pay for you?
They pay you guys so that we can
Yes,
come
no.
together. It's a business stuff.
So permutation, that's where we're going to start from. If you want to
This is
permutate
good,
1
yes,
and 2,
Hey!
Well, so it's better than one. Better than no, you didn't see our own, man.
how many permutations can we get?
What?
The
One and two?
permutation of this is equal to 1, 2, is the set 1, 2, comma, 2, 1. These are all the possible orders that you can have of this.
Yes.
So if you have 1, 2, 3, then the permutation will be what? 1, 2, 3, 1, 3, 2,
3 to 1.
3, brother, please let me know. 2, 1, 3, 2, 3, 1, 3, 1, 2,
3, 2, 1.
3, 2, 1.
That's 6.
So these are all the possible permutations you can get. Now, if I'm giving maybe 2, 1, 3, and I want to rearrange it to get 1, 2, 3. I will do, if I swap 1 and 2, I have 1, 2, 3, and I'm done.
So one transaction.
So this is one, one.
Is it 1 or 2? Okay, one swap. Just one swap.
And we call this, since this is one swap, the order of this swap is odd. And we call this odd permutation. So if you are given, and they say you should restore it to
The order.
1, 2, 3, 4, 5, 6, 7. What do you do?
Nothing.
Switching one.
This one. And you have to start from the first one, Abi.
Start from moving 1 to where it should be.
One and three.
1 and 6. 1, 6, 7, 5, 4, 3, 2. Next, move 2.
2. Where it
We
is.
have 2, 1, 2, 5, 4, 3, 6,
7.
7. Next, move 3 to
Three.
where it should be. We have 1, 2, 3, 4, 5, 6, 7. So it's back. I don't. How many we have? 1. This is what you are counting.
Yeah.
2, 3.
Squash.
So that TV apart.
Yes, 3 swaps.
3 swaps. And that's odd also.
Now, another person can do this. 7, 5, 4, 3, 1, 2. It's
Directly
okay.
under them.
1, 2, 3, 4, 5, 6, 7. 4 goes to this, 3 goes to this, 5 goes to this.
They're getting there. I continue.
Now 6 goes to 6. 7 goes to 7. 1 maybe further. That's the problem now. Goes to 1 is when. And then 2, don't fall my hand. Goes to 2. Perfect.
You count what?
So now we're not going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
So you see odd.
Out.
You see odd.
So we have 17
Oh.
swaps.
Well, we didn't swap 4. 4 was already in his position.
You must always align them. So we have 17 swaps. So this is odd permutation. Whether you use this way or you use this way, you will still have odd permutation. Even if it's Obi that did it or it's Dada that did it, they will still have odd permutation.
But the number will also be different.
Now, if your permutation is odd, then the sign for that swap is minus. If your permutation is even, then the sign for that swap is plus. That's the long version of this whole story. Now, the type of permutation, if it is odd, you have minus 1. If it is even, you have plus 1. Okay? Now, so the determinant of the matrix A. Let A be an n by n matrix. Then, first of all, before I conclude, if you have a permutation that is odd, we write the sign as sigma of p. Sigma of p can be equal to minus 1 if it's odd, and is equal to plus 1
If
if it's even. Thank you for keeping quiet. God bless you. Let determinant let A be an n by n matrix. Then determinant of A is equals to summation I is from 1 to n sigma p A1 P1 A2 P2 A3 I will explain the one P3 up to AN. So, for example, if you have a 2 by 2 matrix, we know that I is either 1 or 2, right? And we saw that the permutation is 1, 2, 2, 1. Isn't it? Right?
Yeah.
This number will shortly is 0 to return back to the original position. So it's plus, right? Follow me now. 1, 2, 1, 2, nothing to do, 0 is even. So it's plus 1, right?
yes.
That's sigma of this is plus 1. Call this P1. Then sigma of this is minus 1. how do we use this formula to get the determinant of A? Determinant of A is equal to sigma of P. This is sigma of P. 1 plus 1, right? Times A, 1, the first term is 1. So this is P1, P2. P1, P2. Okay? So A, 1, 1 times A, 2, 2. Because this is P2. P2 is 2. Now the sign of sigma of P here is minus 1. So I'm adding minus 1 times A, 1, P1 here is 2. P2 here is 1. So you see that you have the formula A11, A22 minus A12, A21. We can do it for bigger ones, for 3 by 3 matrix, or 4 by 4, or even 100 by 100. You just need to know the number of permutations. So for 3 by 3, we have 1, 2, 3. And we've already permuted, we did it before. We said 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, right?
Yeah. The 3, 2,
3, 2, 1,
3, 1.
3, 1, 2. So if I want to use this formula, the first thing I need to do is get my sigma of P for each of them. Now, if I relate this to 1, 2, 3, the number of swap is 0, right? It is even, and if it is even, it's plus 1.
That's good.
If I relate this with 1, 2, 3, the number of swap is 1,
Yeah,
which is odd. So we have minus 1. If I do 1, 2, 3, 1, 2, that's all, just 2. Plus 1, so this is minus, right? The same thing, 1, 2, 3. 2, 3, 1. 1, 2, even.
Yeah, 2.
Plus 1. 1, 2, 3, cannot follow in right way back. It's just 1, which is minus 1. You have 1, 2, 3. Swap 1, 2, 3. So you have 1, 2, just 2. So you see the reason why I thought the 2 of them. If not, you would have swapped first, then gone down again, swapped again. It takes time. So we have 2, and this is plus 1. One way to check that you are correct, the number of even is usually equal to the number of odd. So we check how many plus 1s do we have? 1, 2, 3. 1, 2, 3. So we are correct. We can now apply the formula. So determinant of A is equals to, the first sign here is 1. So I just need to do A, 1, 1 times A, 2, 2 times A, 3, 3 minus A, 1, 1, A, 2, 3. You understand? A, 3, 2 minus A, 1, 2, A, 2, 1, A, 3, 3 plus A, 2, sorry, 1, 2, A, 1, this is where we are, 1, 2, A, 2, 3, A, 3, 1 minus A, 1, 3, thank you, A, 2, 2, this is where we are, and now here now, A, 3, 1. And then finally, we have plus A, 1, 3, A, 2, 1, A, 3, 2. And that's the determinant. So they can say use the determinant formula to find the determinant of a 3 by 3 matrix. So you use the formula first and write it down. So for example, now if you are given this 3 by 3 matrix, 1, 0, 5, 3, 2, 1, 0, 0, 3. How do we find this? We know that this is A11, A12, A13, right? This is A21, A22, A23, A31, A32, A33. So the determinant of this matrix will give us A11, 1 times A1, A22 times A33, 0, minus A11, 1, A23, what's A23? 1, 2 A23, 1, A32, this is A32, 3, minus A12, 0, I don't need to write any other thing, plus, so we are here now, A12 is still 0, minus A13, where's A13? 5,
But there are more methods than classes, I mean.
A22, 2, A31, 0, my plus A13, 5, A21, 3, A32, 3. And that's alright? So 0, 0, I don't need them. Everything I tell, I'm going to cancel them out so that I can see root. And then I have minus 3 plus 15 times 3, 45. 42. And that's the determinant of our matrix. Bye! See you another time. Thank you for watching. Let me do it again. Thank you for watching. Please like my video and
Let's agree where we stand.
thank you for watching. Once again, I'm Joanna Mara. Please subscribe to my channel. Bye.